All right, let's look at the greatest integer function. It is also called the floor function. I actually am more familiar with the floor function, or used to floor function than greatest integer function. All right, so this textbook uses this kind of a fat bracket of x. And the floor function, you have this little, L and L backward, this symbol, x, so it's a floor of x. This is defined as the largest integer less than or equal to whatever inside, in this case, x. All right, so for example, all right, what would be the greatest inner function of 3.2? Right? So it might be helpful to look at the number line, right? So you have a number line, and let's say you have a 0 right there, and then you have a 1, 2, 3, 4. So there's a 3, there's a 4, and you can see that 3.2 is sitting around here. It's about, so this is about 3.2. Right? So obviously, if you're looking for the largest integer, less than or equal to 3.2 would be, in this case, 3, right? So this is going to be equal to 3, right? It's a piece of cake. All right, how about the negative 3.1? Sometimes it's very tempted to say, oh, it's going to be negative 3, right? But if you think in terms of number line, so you have a 1, -1, -2, -3, -4. So this is -3, and this is -4 right there. Right? If you think about negative 3.1, so it's going to be a little bit smaller than -3. So it's sitting right here, right? So this is negative 3.1, right? So if you're looking for the largest integer less than equal to negative 3.1, you can see that it's actually -4, not -3. So it's -3, -4. All right, so we got that. What if you take the greatest integer function of an integer? It's going to be so greatest integer function of -3 is obviously the same integer, -3. All right, so it's fairly easy to come up with. You just have to be a little bit careful, especially on the negative side. All right, so how about sketching the picture? All right, can we sketch the picture of y equals floor function of x? All right, so a floor function or a greatest integer function is a little too hard. So I'm going to start with y equals x. All right, so I know how to draw the graph of y equals x. That looks like this. It's just a 45-degree line through the origin. All right, slope is 1, right? So this is y equals x, right? So what kind of changes do we need to make if you take the floor function of that, right? So you can see that if it's 0, it is 0, right? But you can see that these values are fractional values, so 0.1 or something like 0.2, 0.3, and so on. So up until this point, it's going to be less than 1. So all these guys is going to be pushed down to 0. But right at that it hits 1, it becomes 1. So it's going to go up to 1. Right? So you have an open circle there, and then it's going to go up there. All right, so these are going to be 1.1, 1.2, 1.3, and so on. So if you take the floor, it's going to become just 1. So it's going to stay at 1, but right at hitting 2, it becomes 2. Right? So you can see that you're going to have this kind of like a step function, right? The same thing here, so -1, but all these guys going to stay here. And here you're going to have a -2, but it's going to stay -2, right? So this pattern keeps on repeating. So this is what the graph of the greatest integer function of x looks like. All right. So what if you want to do a greatest integer function of 2x minus 1? All right, so let's do the same approach. Let's try to sketch the graph of, say, y equals 2x minus 1, right? So you just have a straight line. So slope-intercept, y-intercept is a -1, so it's going to go through there, right? And the slope is 2, so you go to the 1 unit, you're going to go up 2 units. So it's going to go through that point, and you're going to go through here, you're going to go up 2 units, so it's going to go through there. And let's see if you're going to go back there, so it's going to go down 2 units, so it's going to go through there. And if you even go there, so we're gonna here have that. So I'm gonna just more or less, this is gonna be the picture. So slope is 2, and the y-intercept is -1, right? So this is the picture. All right, so let's sketch the, so what if we take the, greatest integer function of that, right? So we know that, let's start with something. So here, I know that this is -1, right? So I'm gonna go through there, right? And here, this is 1, so it's gonna go through there, right? But in between, it's going to be pushed down to, up until this point, it's gonna push down to -1, right? But once you hit that point, it becomes 0, so it's going to be 0, and then it's going to be 0 0.1, 0 0.2, and so on. You're going to have this, so we have that. And then you're going to have the same pattern. So you're just going to go 1/2 there, and it's going to jump up, and it's going to go here, and you're going to have a circle there, and so on, right? And you're going to have to go up here, and you have that, right? Same thing, it's going to hit the integer here, and the here go here, and it's going to hit the, let's see, it's kind of hard to draw, but the here is here, and you have that, and so on. So I'm going to just, it's really hard to see now, but this is how you sketch the picture, right? So the pattern keeps on happening, right? So all the fractional value is going to kind of truncate it to a lower integer value. Right, so the graph of these guys looks like a step function. So, so I guess sometimes these are called the step function, but the graph of these guys look like this. Right, so that was greatest integer function. I hope that this was clear.